Alright guys, welcome back. Today we are going to be looking at graphing rational functions. If I look at example 1, or looking at some examples, graphing rational functions is kind of putting together everything we've done so far. I need to identify the horizontal asymptotes, I need to identify the vertical asymptotes and poles, and then I need to just kind of figure out where my graph is going to be. Okay? So it's kind of like just what we were doing yesterday, kind of putting the two parts together. So if I look at A, I have f of x equals 4 over x minus 3. We always want to start by factoring, but the first thing I know about this is I can't factor 4 and I can't factor x minus 3. So this is kind of nice and easy. It's already done for us. So the first thing I need to figure out is my horizontal asymptote. Okay? My degree of my numerator equals 4. Degree of denominator equals 1. Sorry. Ooh. The degree of the denominator does not equal 4. The degree of the numerator equals, there is no x, so it's 0. That makes no sense. 0 is less than 1, right? You gotta think about what case this is. This is y equals 0. Okay? So, at y equals 0, here's y is 0. This is my horizontal asymptote. So it has to go horizontally. So it's going to go straight through my graph like that. The next thing I need to worry about is any vertical poles or vertical asymptotes. Okay? So poles. Well, nothing cancels here. So there's none. Vertical asymptotes. Well, I have x minus 3. Right? So if x minus 3 is my factor, x equals 3 is my 0. So now I'm going to put a vertical line at x equals 3. My last step, step 3, is to make a table of values using my function. Okay. When I make a table of values, right, how do I know what numbers to choose? I'm going to go 2 to the left of my vertical asymptote. So my vertical asymptote's at 3, so I'm going to choose 1 and 2. I'm going to go 2 to the right. Okay, so 4 and 5. And then all I am going to be doing is plugging these right into my calculator. One is, right, I'm just going to type it in just like that. Let me get to the calculator. 4 over 1, right, so I'm plugging in 1 minus 3. And then when you type in 4 over 1 minus 3, if it's not off the graph, you get negative 2. So 1 is negative 2. I'm going to do the same exact thing for 2. 4 over 2 minus 3. And you get negative 4. And you'll just continue in that manner. For sake of time, we'll just kind of go through it, but when you're trying to find your values, you're really just plugging in. So 4, and then I plug in 5, I get 2. So then, all I need to do is put these numbers on my graph. So 1, negative 2 is here. 2, 4, negative 4 is here. 4, 4 is here. 5, 2 is here. All right, and all this tells me is kind of how this moves, what side of my asymptote is on. And then I kind of just follow the asymptotes, right? I follow the center. And that's it. All right, let's look at another example. Let's look at D. I'm given x squared plus 7x plus 12 equals negative 2x squared minus 2x plus 12. So the first thing I need to do is completely factor. Before factoring, you need to do your horizontal asymptote. Well, degree of n equals 2. Right, degree of b equals 2. 2 equals 2. Right? So the degree of my numerator equals 2, the degree of my denominator equals 2, and 2 equals 2. So then I'm just looking at my coefficient. So y equals 1 over negative 2. So y equals negative 1. So it's going to be right about here when I draw it in, right under those numbers. Right in between 0 and 1. It doesn't have to be super exact, right? Just close enough, right, for negative 1/2. Alright, then. My next thing is holes. Before I do anything with holes or asymptotes, I do have to factor. So if I look at my numerator, I need something that multiplies to 12 but adds to 7. That's going to be x plus 3, x plus 4. If I look here, I first have to take out my common denominator. Remember, this is negative. We don't like negative numbers. So I'm going to take out a negative 2. I'm going to have x squared plus 1x minus 6. And then I'm going to factor this trinomial, so I still have x plus 3 on top, x plus 4, all over 2 times. I want to add to 1, but multiply to negative 6, and then I have x plus 3, x minus 2. So, holes. Where are my holes? Well, x plus 3 and x plus 3 cancel out. If x plus 3 is my factor, x equals negative 3 is my 0. I can't put my hole on my graph yet because I don't know the y value. We'll figure that out in a second. Okay? But I am going to find my vertical asymptote. Alright. That's based off of this x minus 2. So if x minus 2 is my factor, x equals 2 is my 0. So I'm going to put a vertical line right at x equals 2. Now, when I find my table of values, it's still the same. Okay? I want to go to the left and to the right of my function. Okay? So, I'm going to choose 0, and I'm going to choose 1. And then the other side of my vertical asymptote, I'm going to choose 3 and 4. The last thing I need to do, which is a little bit different, is when you have a hole, I also need to find where my hole is. Okay? The left to the right and your hole. Okay? Now, when I plug in, I am only going to plug into my reduced function. By that, I mean I'm going to plug in 2 x plus 4 over 2 times x minus 2. X plus 3 is gone. Cross it out. Okay? So, on my calculator, I'm going to control division. X plus 4, well, x is 0, so 0 plus 4 over 2 times x minus 2, 0 minus 2. So we get negative 1. And then again, I'll keep doing that by just typing all those into my calculator. Again, for sake of time, I'm just going to tell you what the numbers are. So we got 0. I forgot a negative 2. Sorry, guys. At some point in time, my negative got lost on my 2. It should be x plus 4 over negative 2 times x minus 2. So this is really positive 1 because of that negative there. And then if you continue to type this in, you get 5 halves. And then for 3, you get -7/2. For 4, you get -2. And for -3, you get -7/10. Yes, sometimes you will get kind of crazy fractions. That's okay. Okay? So if I go to 0, I'm going to be at 1. At 1, I'm going to be at 5/2. So if I think about halves, I'm just going to count halves. Right? 1, 2/2, 3, 4/2, 5/2 is there. Right? So just cut. So just kind of cut your units into whatever fraction and count that way. 3 is -7/2, so I'm going to cut everything into halves and just count halves. 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, 7/2 will be in between -3 and -4. 4 is at -2, so that's here. And then -3, I need a whole, so an open circle at -7/10. So that means at -3, I am going to go -7/10. So it's not quite to 1, right? And I'm going to put an open circle. Again, it doesn't have to be super exact. I understand -7/10 is a small measurement. And then again, I'm connecting. I'm coming along the fence, right? I hit that -7/10. I skip it, right? Just the hole, and then on this graph. Always just go along the fences. All right, let's look at one more example. I think we have time for. This is another one that got off on mine, but it's right on yours. On yours, it does say -3x plus 12. I don't know why it doesn't on mine. So it should be -3x plus 12 over x squared minus 3x minus 4. So when I start, the first thing I need to do is find my horizontal asymptote. Right? So the degree of my numerator is, right, there's just a 1x. So is that the degree of my denominator is 2, that x squared there. Not x. I keep writing random things for the degree of the numerator. It's 1. There's 1 x to the first, so it's 1. So 1 is less than 2. So this is when it's less than, it's y equals 0. Now, before I do horizontal asymptotes or vertical asymptotes, I need to factor. So I'm going to pull out a -3. I'm left with x minus 4. Then on the bottom, I'm just going to factor, multiply the -4, add -3. That's x minus 4, x plus 1. So, looking for wholes. Right? Anything that cancels out, I have an x minus 4 and an x minus 4. So that means if x minus 4 is my 0, x equals 4 is my, if x minus 4 is my factor, x equals 4 is my 0. Then I have x plus 1 for my vertical asymptote. If x plus 1 is my factor, x equals -1 is my 0. So let's put our asymptotes in our graph. I have x equals -1 as my vertical asymptote. And then I have y equals 0 as my horizontal asymptote. So then again, I'm just finding my table of values. I have x and y. I'm going 2 to the left of x, 2 to the right of x, and my whole. So to the left of x, I have -3, and then -2. To the right, I have 0 and 1. And then don't forget your whole, which is 4. I always put my whole in a bigger gap down so I remember that it is the whole and not just another point. And remember, I'm typing everything into my calculator without the crossed out part. Negative 3 over x plus 1 is all I've got now. Again, for the sake of time, since we're running a little long, I am just going to tell you what those values are. When I plug in negative 3, I get positive 3 halves. When I plug in negative 2, I get positive 3. When I plug in 0, I get negative 3. When I plug in 1, I get negative 3 halves. And when I plug in 4, I get negative 3 fifths. So, writing these numbers in, negative 3 is 3 positive 3 halves. So I'm going to go up 1 half, 2 halves, 3 halves. So right there. Negative 2 is 3, so up 1, 2, 3. 0 is negative 3, so down 1, 2, 3. And 1 is negative 3 halves, so down 1 half, 2 halves, 3 halves. And then for 4, I have negative 3 fifths, so it's kind of right in the middle. It's a bad football. Let's try that again. Something like that. Again, just make sure it's a nice, clear, open circle. And then connect your dots and follow your fences. There is our lovely graph. Alright, that's all. Since we are running long, that's all we're going to do today. We'll do D tomorrow. We'll finish our last graph. Other than that, have a wonderful evening.